Good evening, students. These are the notes for Tuesday, October 29th's class. We are about to get into Unit 4, and Unit 4 is going to take us into the depths of triangles. We're going to be looking at a lot of different information on triangles. It's kind of the beginnings of our study of the different shapes in geometry. Okay, so we're going to start with triangles. I apologize for the notes being a little late getting out to you today, so I won't waste any more of your time. Let's get right to it. Okay, our objective for today is the student will learn the basic categorical names for triangles. These should be largely review, if not entirely review for you, so this should go pretty quickly. Again, copy your objective, and the date will be Tuesday, October the 29th. Press pause anytime you need more time, and then hit play when you're ready to move on. Okay, now, as we know, Euclid had his basic structures in geometry, and he said everything in geometry can be built out of those structures. The polygons that we work with in geometry are constructed out of segments, and a triangle is the most basic structure that we have in the polygon category. Okay, there's no such thing as a one-sided polygon. There's no such thing as a two-sided polygon. But once you get three sides going, now you have a triangle. And we have some basic vocabulary that goes along with the structure of any polygon. And you may be familiar with this, but go ahead and jot it down. The line segments that construct the boundary of the polygon, or the perimeter of the polygon, are what we call the sides of the polygon. Where those sides join together, a point is formed, and that point is what we call a vertex. Okay, and the plural of the word vertex is vertices. You have one vertex, but two vertices, three vertices, and so on. Okay, now we have a naming system for triangles, just like we have a naming system for everything else. And when we are referring to triangles, we will call them by their name. The proper way to name any polygon, including triangles, is to say what kind of a shape it is, and then list off all of the vertices that are needed to build it. Now, this is not a difficult concept or anything like that, so you can probably get away with not even copying down this example, okay? But here's an example if you'd like it. We have obviously a three-sided polygon, so that would be a triangle. Our triangle has three vertices that mark its corner points. Our vertices for our polygons will always be capital letters, and we can name this polygon by naming what type of a shape it is. It is a triangle, so we will announce the word triangle, and then we will list off the vertices that we have. Typically, they are placed in alphabetical order. That's the most proper way of doing it, to say triangle ABC. However, it is not incorrect to use other combinations of the order of the vertices. Okay, so saying triangle ACB or triangle BCA or any other imaginable combination, those are all correct as well. Okay, so let's take a look at the categories. Okay, first off, here's one you should be familiar with, acute. Okay, acute triangle. Now, we've already spent some time talking about acute angles this year, so we should know that an acute angle measures between 0 and 90 degrees. But what you need to know is that all triangles will have two acute angles in them. All triangles have two acute angles in them. The triangles are named according to the measurement of that third angle. So in all of these cases, if you remove two acute angles, the question is, what is the measurement of the third remaining angle? Well, an acute triangle is going to be a triangle that has all of its angles as acute angles. Okay, so every triangle has two acute angles. If you take two of them away, is the third one also acute? If it is, then you have an acute triangle. And I've provided you with a couple of examples here. Okay, guys, be very careful. It is extremely difficult to eyeball some of the drawings that we're going to have in geometry. You cannot look at some of these figures and decide whether an angle is acute or not. Okay, in the figure on the left side, you can easily see all three angles are acute. That makes it an acute triangle. But looking at the one on the right side, look at that lower left-hand angle there. Okay, sure looks like a right angle, but if that measurement is even a tenth of a degree or even smaller than that, okay, anything smaller than a right angle, that makes it acute. You have three acute angles. Those are acute triangles. And of course, we could have a right triangle. We're very familiar with right triangles, worked with them before, and we will work with them a lot this year. And our definition of a right triangle, it will of course have two acute angles, but the third remaining angle will be exactly 90 degrees. So as you can imagine, there's a couple of examples. You don't necessarily need to copy the examples down, but definitely get the definitions. Okay, and again, a couple of different ways that they can show us we have a right angle in a triangle. They could mark an angle as 90 degrees. They could mark it with the little box. And of course, they could leave the math to be up to us. We might have to solve to decide if there is a right angle or not. I bet you can guess that the next one is going to be obtuse. Okay, obtuse triangles. Once again, an obtuse triangle is going to have two acute angles in it like any other triangle. The difference is the third remaining angle will be obtuse, be somewhere between 90 and 180 degrees. Okay, so here's a couple of examples of obtuse triangles. And again, be very careful. Okay, not always that easy to just look at a triangle and decide that it is obtuse. Better to rely on the math, rely on the numbers. As you can see in the triangle on the left, the top angle definitely higher than 90 degrees, so it's obtuse. And in the one on the right, again, that lower left-hand angle is very, very close to being a right angle, but not close enough. It's not exactly 90, it's a little bit larger. That's going to make the angle an obtuse angle, making it an obtuse triangle. Another term, and this one, it depends on who you've had in recent years for your math classes. You may or may not be familiar with this term, but we've talked about it, I believe, a little bit this year, equiangular. Okay, an equiangular triangle. Well, equiangular is a word that is easy to decode. The prefix equa means equal, pardon me, and angular obviously means pertaining to the angles. Okay, so an equiangular triangle is a triangle that has all of its angles the same measurement. As it turns out, that is going to make all of the angles measure exactly 60 degrees. Okay, that's a small part of a larger property that we will get into a little bit later on. But for right now, just know that in an equiangular triangle, all of the angles will measure 60 degrees. And as you can see on the triangle on the right side over there, they don't even have to give us any measurements to tell us about an equiangular triangle. They might use matching angle congruency marks like that triangle has. All right, so enough of talking about the angle measurements in a triangle. Okay, to this point, we have all of the names that we have discussed have been talking about angle measurements, but we also have categorical names that go along with the side lengths of our triangles, and you're probably familiar with most of these as well. Okay. The first one we're looking at is the term scalene triangle. Well, a scalene triangle is, generally speaking, a triangle that has no congruent sides. All three sides will be different measurements. So a couple of examples of scalene triangles might look like this. The triangle on the left, you can see that we have tick marks on all three sides of our triangle, but none of the three sets of tick marks match. That's one way of them saying that these measurements, whatever they are all different from each other. Or, of course, we might have the numerical measurements to know whether it's scalene or not. If we were to have two sides the same, we would then call it isosceles. An isosceles triangle is a triangle that has at least two sides congruent. Now, you're familiar with these before now, and I know some of you are thinking, why do I even have to copy this down? But this is a definition we actually need to pay a little bit of attention to, and please copy it the way that I have it written. And a triangle that has at least two congruent sides. Okay, we'll come back to that definition here in just a moment. A couple of different ways that this could be shown to you. You can see that we have differing tick marks on the figure on the left, and we can see that two of the sides of tick marks match. That's going to show us that we have congruent sides in two places. And on the right side, of course, we have the measurements. Now let's go back to that definition and talk about this term at least. Why does it say at least two congruent sides? That's actually a very important point, which you probably have not been exposed to yet in junior high. Now, we should know that it is possible for a triangle to have more than two sides congruent. It definitely could have all three sides congruent. Okay, but the question is, even though it has more than two sides congruent, does that change the fact that it still does have two sides congruent? Okay, obviously it does not. Okay, but we run into a little bit of a technicality here. A triangle could have all three sides congruent, but that does not stop it from technically being isosceles. Okay, so the term isosceles still applies, and when it comes down to isosceles triangles on standardized tests and stuff like that, the test writers like to pick on this little fact, so we need to make sure that we know it. However, when a triangle does have three sides congruent, we have a new name for it as well, and that name is equilateral. Can't remember if we've mentioned this one this year or not, but if not, here it is. The prefix equi, once again, means equal, and lateral means away from the middle. And if you think about a polygon, what is away from the middle of the polygon? Those are the sides. Okay, so equi, meaning equal, lateral, meaning sides, equal sides. An equilateral triangle is a triangle that has all of its sides congruent. So as you can imagine, a couple of examples of equilateral triangles might look like that. We have matching tick marks on all of the sides, or matching side links on all of the sides. And as we said, these triangles are also isosceles, but technically, more precisely, they are equilateral triangles. So that's the basic categorical information for triangles. We need to be able to classify triangles into these categories. And as you can probably figure out, we have a description, at least one description to tell triangles about their angle measurements, okay, and at least one description to tell each triangle about its side lengths. I appreciate you tuning in and getting your notes. I'll see you in class tomorrow.